Today we'll talk about factoring by the grouping method. To factor by grouping, there are three simple steps. Step 1, you need to group the terms in your polynomial into two separate groups, each having a common factor. This is sort of like splitting the polynomial into two parts. Next, you will factor out the GCF from each half of the polynomial. Last, you will factor out the common binomial factor. Let's take a look at this example. If we split this polynomial down the middle, it virtually creates two groups, a front and a back group. In the front, you will notice that there is a GCF, a greatest common factor, for 15 and 10. That is 5. The common letter is x, and you always go with the smaller exponent. So 5x squared is basically the greatest common factor for the front half of this polynomial. Divide by 5x squared. 15 divided by 5 is 3. x3 divided by x2. Now remember, subtract the exponents when you're dividing these. That will leave x1. Bring down the minus sign. 10 divided by 5 is 2, and of course there are no x's left over. Now bring down the plus sign that connects the front and the back halves of this problem. You will notice in the back I have 6x minus 4. The greatest common factor for those two terms would simply be a 2. So now I will take the 2 and divide both terms in the rear of this problem by 2. 6x divided by 2 is 3x. Of course, 4 divided by 2 is 2. Now you will notice there is a common binomial in parentheses, both in the front half and the back half of this polynomial. Take that common binomial, it'll always be in parentheses, and place that in the front of your answer. Next, divide the front and the back of the polynomial by that binomial that you've just factored out. When you do that, it leaves you with 5x squared plus 2. This is your final answer. Another example, we split the problem down the middle. In this example, the only thing that is common to 2a squared and 5ab is simply the letter a. So that is my greatest common factor. I divide the a out of both the first and second terms. That will leave 2a plus 5b, noticing that the a canceled completely where the 5b had occurred. Bring down the plus sign, and if you look at the last two terms, 2a plus 5b, there is no number that will divide into 2 and 5, and there's no letter in common. The only common factor they have is the number 1 itself. So I divide both those terms by 1. Of course, when you divide anything by 1, it really doesn't change that term. Now you can quickly see the common binomial that sits in the parentheses. Put that 2a plus 5b GCF in the front, and when you divide 2a plus 5b out of both the front and back half of your polynomial, it leaves you with a plus 1. That is your final answer. Now in this last example, if you split this problem down the middle, notice there is no common factor to the front nor the back. I couldn't get any further than that. But I could rearrange the terms a bit. How about I switch these two terms in the middle, making this now 3xy minus 3x plus 2 minus 2y. Let's try separating the polynomial now. I can see quickly that 3x is the greatest common factor for the front half of this polynomial. If I divide this out, I see I have y minus 1. Then in the back half, I quickly see, after bringing down the plus sign, that I have a 2 that will divide out of both terms. And if I divide both those by 2, I have 1 minus y. Now if you notice, my common binomial here is not exactly matching up. To take care of this, I can simply change this positive 2 into a negative 2. And that will change the order and the signs of the terms inside that parenthesis. It's a little mathematical trick that you don't use a lot, but it is helpful. Final answer then is simply y minus 1 times 3x minus 2. Good luck on your factoring by grouping.